Hello, everybody. Let me present you Arkadia Space, the company that wants to change the paradigm in the propulsion sector. Next slide, please. As you know, and especially with Elon Musk and SpaceX, the entry barrier of space, which was accessing to space, the cost of rockets is now cheaper than ever. Now there is much easier for companies to put satellites and infrastructure into orbit. Next slide, please. And this enables us a new market, what we call the space logistics market. Now companies can provide services in orbit, like space transportation, satellite reparation and refueling to extend the life of satellites, and one of the most important ones, space junk removal. At the end, all these companies need mobility. Next slide, please. And how a satellite or a vehicle moves in space? Well, at the end with engines, like any other vehicle. But we have a problem. In the next slide, please. Traditional engines are not the right option of this new market for these emerging companies. The technology was designed 50 years ago with the technology back then, and also with the requirements back then. Also, they use very toxic propellants like hydrazine and derivatives, which makes the operation and the development cost of these engines very expensive. Next slide, please. We want to develop and we want to change the paradigm of the engines in space with innovative design, making use of advanced techniques like 3D printing, but also using green propellants, in this case, hydrogen peroxide. And with this, it will enable a drastic reduction of the cost, up to 60% compared to traditional engines. Next slide, please. This is what we aim to completely replace engines that are using hydrazine with engines that use green propellants. And we expect that by 2030, 70% will be those using green propellants, especially that in Europe, for example, and in other countries as well, like the US, the hydrazine will be banned. In Europe is with a rich regulation. Next slide, please. This is the product we propose, a modular system where we have different engines and different tanks, and the customer can customize the system so that it can better adapt to the needs. Next slide, please. And we bet for the orbital chemical propulsion market, which is growing drastically a lot these years, annually at 22.5%. We estimate that will be 2.5 billion by 2030 in a global market, the in-space logistic market of more than $50 billion. Next slide, please. This is how we stand against competition. There are already a couple of companies selling products, but we stand out of them because of the technology we have selected, which is scalable and makes us serve the entire value chain of the space logistic market. We will also not have any restrictions in terms of exporting with ITAR. We'll be ITAR free, and also we will be very competitive in terms of cost. Also, in the next slide, we will have a very important competitive advantage. We will have our own testing facilities. We have signed a contract with the airport of Castellón in Spain, and we'll be the only 100% privately managed center in Europe. With this, we will have very fast iterative and design cycles with the design and with the testing. Next slide, please. You see already the advance. We already signed the contract. We have our offices there, and we will be having operative the test site in the next couple of months. You see where we stand, the company, in the bottom left of the slide, close to the beach and making rocket engines. What a better place to do space propulsion. Next slide, please. At the end, what we do is design, develop, and sell engines for all these companies. We have talked to most of them, trying to understand the requirements, to understand what are the pains they have. And with some of them, we have signed already 8 letters of intent valued more than $10 million. Next slide, please. The most important asset of the company, the team. The founding team was the leader of the first rocket engine ever made in Spain at PLD Space. In the next slide, we have been working for more than 5 years together, 4 years at this rocket company in Spain. And we also count with 2 amazing advisors working in big companies like Abengoa, civil engineering group internationally, but based in Spain, and also Franz Asgeber at the European Space Agency. Next slide, please. This is where we stand today. We constituted the company a year ago, and we have closed already a pre-seed round, and we have signed the contract with the Airport of Castellón. And with this year, with the money, we will develop the testing facilities. We will have our first prototype, the minimal viable product. We are now looking for convertible notes to have next year the second MVP and the first test flight, which is very important for a space company. Next slide, please. And this is what we are seeking now, and we will look for you guys to join our vision. We are asking for or looking for $3.5 million, half in equity, half between debt and grants. It will give us 18 months of runway, and we are now giving 20% discount in convertible notes. Next slide. For this space revolution, the first thing that was needed was accessible to space transportation. We made it with rockets, thanks to SpaceX and all these companies chasing them. But now we need also accessible in space transportation. And this is where Arkadia stands. And this is just the beginning. First, we'll be in low Earth orbit. In the next slide, you will see that with the same technology, we want to go beyond. Thank you very much.
Awesome. We'll open up the floor for questions. If you have a question, you can jump right in, or you can raise your hand, make it a little easier on the ordering.
Go ahead.
Thanks. I was about to jump in. Great presentation. I'm curious, are you building the engines and focusing there, or will you have plans to build any type of space tug or vehicle yourselves and software capabilities for rendezvous, et cetera, et cetera?
The plan of the short to medium term is just to focus on the propulsion technology. So our customers would be those companies developing space tags. Actually, we have talked already with some of them, especially in Europe, like D-Orbit, which actually now announced a SPAC, or Excellence. In the US, we will have a space flight. So today is the propulsion technology, but we aim for, in the long term, to develop the entire platform, to provide mobility all over the solar system. But this is more the long term of the company.
Are you focused on certain types of satellites, low orbit, or you're looking at the whole range of the satellites?
Very good question, and I didn't mention it. The thrust range we target is from 5 newtons above. So this discards the CubeSat market. We believe that the CubeSat market, even if will be very important, there are very many companies out there providing both electrical and chemical propulsion solutions, which is very difficult sometimes to say what is better. Both sometimes are better. At the same time, we believe that the purchasing power of this market is not the one that the companies with bigger platforms have. So we target platforms, satellites above 50 kilograms. 100 kilograms would be more or less the minimum, and above.
So I've got a couple questions. So this requires a special engine that is unique to the fuel. Is that correct?
Absolutely.
And is this used for launch or only spaceborne propulsion to move the asset around?
Let's say that we have as you mentioned, you design the engine around the fuel, and you have two different fuels. Fuels for rockets, which usually are cryogenic, and fuels which are storable, which are the ones that you use on orbit, because you have to maintain the properties of the liquid for a very long time, and you cannot use cryogenics, at least with the technology that we have today. So answering to the questions, it will be just for, with the fuel we will select today, just for orbital purposes, not for rockets.
And not to hog the channel, but if I go one further, then my real question is if you could contrast the packaging and the real estate required on the satellite with a conventional engine and conventional propulsion. No, again, for the same thing. You design the engine around the fuel. So it's not that you can replace the fuel and you can use it, if this is the question. No, I get that, but is your engine smaller? Is it bigger? Do you require more or less storage capacity for the onboard fuel?
It's 1-to-1.
1-to-1. Okay, thank you.
It's 1-to-1. It's a complete replacement of the engines in the different category thrusts. Thrust category, sorry.
Thanks.
I'm kind of curious quickly what kind of hydrogen you'll use and where you'll get it.
It's a hydrogen test peroxide. concentration, very high concentration, 98. Typically in the space sector at the beginning, it was 60, 70%. Now you can get 98% commercially. In Europe, there are already a couple of companies providing it, Evonik and Jacuz. And actually Jacuz, for example, is the one providing for the Soyuz rocket. In order to start up the turbopumps, you use peroxide, hydrogen test peroxide, and Germany and Poland are both companies that already commercially you can get it from them.